Hey students, this is lesson 7.2. In this lesson, we're going to learn how to write numbers in scientific and standard notation and to compare and order numbers using scientific notation. Go ahead and do the review. I'll check back with you. All right, I hope you noticed the definition of scientific notation. You're going to need that to understand whether a number is in scientific notation or not. We'll go over that a little bit here. To be written in scientific notation, this number here, the first number, and let's just give an example here. This number is written in scientific notation if the absolute value of A is between 1 and 10, including 1, but not including 10, and the base is 10, and the power is an integer. Okay, so that's a review. So looking at this first one here, is this number absolute value of 8.15 between greater than or equal to 1 but less than 10, and it is. We have a power of 10, we have an integer for an exponent, so that one is yes. This one here, we have a number that's greater than 10, so we're going to say no. 12.9 is not, the absolute value of 12.9 is not between 1 and 10. So that number is too big. And then the last one, that one is written in that scientific notation. This number is greater than or equal to 1. We have a base of 10. We have an integer power, so that one is written in scientific notation. So, yes. All right, you try that. See if you can recognize scientific notation. All right, so to write a number in scientific notation, we need to come up with a number between that's greater than or equal to 1 but less than 10 that we can use for the number. And this number here, we're going to use 1.8. Then we need a power of 10 that will get us this number, which in this case is 18 million. So basically, we have to think of how many times will we have to multiply by 10. Well, the nice thing about multiplying by 10 is every time you multiply by 10, it moves the decimal one place to the right. So we can just count how many places between where the decimal is, between the 1 and 8 to the end, and that's 7 times. So we need to multiply by 10 7 times in that case. All right, and then for a really small number like this one, again, we need a number between that's greater than or equal to 1 but less than 10, and that number would be 2. And then we need to multiply by a power of 10 that will move the decimal to the place to the left from that place all the way to there. And to move it to the left, that means we're dividing by 10, and it turns out that every time we have one less power of 10, that's the same as dividing by 10. So we can just count how many places there are from the end. That's 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's the negative power of 10 that we need. All right, you try that. All right, to put a number in standard notation, we're just kind of reversing the process. Remember, if it's a positive power of 10, then you're multiplying by 10. That's going to move the decimal to the right. If it's a negative power, then it's dividing by that base, 10. So that's going to move the decimal to the left. So we're going to start with 2.8 on this one. And since it's a positive power of 6, that means the decimal is going to move to the right 6 places. 1, 2, 3, 4, 5, 6. So we need to fill in those places and then change the number to 2,800,000. All right. And now this paperclip has a negative power of 10, so that's going to be dividing by 10. So we start with 2 in the decimals right there. Every time we divide by power of 10, it moves it to the left 1 place. So we need to move it 3 places to the left. So 0.002 is the same as 2 times 10 to the negative third. All right, you try that. All right, to compare numbers in scientific notation, we can use the powers to kind of help us tell if it has a higher power of 10 and they're positive numbers, then it's a bigger number. So, and then if they have the exact same power, we can just compare the number out front that's being multiplied. So for these two, we have to compare that number out front, but for this one and this one, since they're all written in scientific notation, we know that that 10 to the third power is going to be the smallest. So we're going to start with that as number 1. Our greatest is going to be 10 to the 6, so that's going to be our 4. And since 5.9 is greater than 4.5, that will be our third biggest, and this one will be our number 2 in this list. All right, so to write them in order, I have 1.5 times 10 to the third, 4.5 times 10 to the fourth, 5.9 times 10 to the fourth, and 1.5 times 10 to the sixth. All right, you try that out. All right, problem 5. We're going to use scientific notation again here to order numbers from least to greatest. And again, we're going to, well, these numbers are not written in scientific notation, so the first thing we want to do is put them in scientific notation. And to be in scientific notation, this first number here has to be between greater than or equal to 1 but less than 10. So I'm going to make that 1.86. Now, to make that 1.86, I'd be dividing by 10. So to get this number to be equal to the original number, I need to multiply by 10 one more time. And doing that is just adding 1 to the exponent. Negative 3 plus 1 is negative 2. Okay. The second number is already written in scientific notation, so I'm just going to write that one down. The third number, we will have to write that as 3.4 times 10 to some power. Now, to get that 3.4, I made that number bigger. And the way I do that is by multiplying by 10 2 times. So to get it back to the original number, I need to take away 2 powers of 10. So 2 minus 2 is 10 to the 0 power on that one. And then the last one, I need to move the decimal 1 place to the left, so 2.13. And when I do that, I'm making the number smaller, so I'm really dividing it by 10 one time. So to get it back to the original one, I need to multiply it by 10 one more time. And so that's adding a power of 10, and negative 2 plus 1 is negative 1. Okay, now that I have them in powers of 10, I can just compare them from least to greatest. The lowest power of 10 is going to be the smallest, so 1.86 times 10 to the negative second comes first, then 2.13 times 10 to the negative first, and then 3.4 times 10 to the 0, and finally 2.13 times 10 to the negative first, or 1.84, that is. But I should write the numbers as they were originally. So, so this number is the smallest, and that's this. So 18.6 times 10 to the negative third comes first. And my second smallest is this one, which is right here, 21.3 times 10 to the negative second. Then this number here, which is 0.034 times 10 to the second. And finally, this one, which is 1.84 times 10 to the third. All right, you try that. All right, we're up to the lesson check. Go ahead and do that, and we'll talk about it next time we meet in class.